Alright, so number 4 in your packet is asking you to add the rational expression xy, or x times y over 5, plus 2 over 5, or 2/5. So same logic as rational numbers, we have to make sure we have a common denominator. And we do. They're both 5s. Okay, so that's good. That's a good thing. So now we just look at our numerators and we want to add them. So we have xy plus 2. So now you just have to ask yourself if those are like terms. Do they have the same variable and exponent attached? So the 2 is just a whole 2. There's no variables attached to the 2. So we can't combine them. These are unlike terms. So how we would solve on number 4 is we're just going to write an expression of xy plus 2 as our numerator, because we can't simplify that anymore. And our denominator, just like rational numbers, our denominator when we add them stays the same. So we just have xy plus 2 all over 5. Okay, so it looks a little more intense, but it's the same logic as adding or subtracting rational numbers. Number 5, we have 7x squared over 2 minus x over 3. So how this one is different than number 4 is our denominators are different, right? And we know that when we add or subtract rational numbers, our denominators need to be the same. So we want to make this 2 and 3 to be the same number. So this is where I suggest to write it vertically instead of horizontally. So we have 7x squared over 2 minus x over 3. And again, that's just preference. That's just how I like to do it and teach it, is writing them vertically like that. It just really helps show this process of finding that common denominator. It really helps show that. Okay. So we need to think of a number that both 2 and 3 go into evenly. So like I said before, you always should ask if the smaller denominator goes into larger evenly. So does 2 go into 3 evenly? Not evenly, so it doesn't go in there. So we need to think of numbers 2 goes into. So 2 goes into 2, 4, 6, 8, 10, right? And 3 goes into 3, 6, 9, 12, 15. So both of these numbers go into 6. Another shortcut way to find your common denominator is to multiply these two, especially if they're small numbers. 2 times 3 gives us that 6. So now we need to raise up our fractions or find an equivalent fraction. So it's kind of like doing two steps within. We're not even getting into subtracting yet. We're just raising these up to like denominators. So if we just look at this first one, 7x squared over 2, we just need to figure out how many 2's are in 6. So 2 goes into 6 3 times. Okay. So if we multiply this denominator by 3 to get that 6, we have to multiply our numerator by 3 as well. Okay. So 7x squared times 3 means I just have 3 7x squareds. So I could just look at my coefficient here of 7 and multiply my 3 by 7, I get 21x squared. So it's like I'm taking 7x squared plus 7x squared plus 7x squared 3 times. I now have 21x squared. Okay. Now let's look at our bottom fraction here, x over 3. So 3 goes into 6 twice, and then x times 2. You could write x2, but just more properly would be 2x. Okay? 2 times x is the same as x times 2. Writing the number first as your coefficient is just more proper. So now we have 21x squared minus 2x all over 6. Okay? And we can look here, and we should probably ask ourselves if our numerator can be simplified at all. 21x squared minus 2x. So while both of them have, terms here have x in them, the exponent also has to be the same in order to combine them, or in this case subtract them. So we can't do any more here. For our answer for number 5 will just be 21x squared minus 2x all over 6.